If I don't, I can't use these definitions. These definitions are only for a unit circle. Now, Ignacio, you now said it. If I square this, x, I get 3, what, 3 squared is 9? If I square the y, that's what, 16? Does 9 plus 16 give me a 1? No. This one, if I square 1/4, I get 1/16. Add to it, I'm using this right here for a little test. If I square radical 15 over 4, do I get 15 over 16? Well, those add up to a 1. Therefore, I can use the definition. Here, you've seen this one before, in fact. If I square radical 2 over 2, you're going to end up with 2 over 4, which is 1/2. Another 1/2, and you're going to end up with 1. That's why I can use the definition. Up here, if I test this one, if I square radical 3 over 2, guys, what is radical 3 over 2 if you square it? Help me out. A radical 3 over 2 and you square it. What are you going to end up with? 3 over 4. Of course, if you square 1/2, that's 1/4. Add them up, you get 1. The only one that does not work is this one. So the answer is wrong. The cosine E is not 3. So these are only for a unit circle at this point. So be very, very careful on the test there. So I'll point that out first. Now, with that said, though, here goes. I'm going to jump right into it and try to get your mind back to where we were on, I guess, Wednesday of last week. Part 2. Find the exact value, no calculator, of these expressions. I have some of these on the exam on Wednesday. Give me a chance to copy these down, and we will discuss what on earth is going on. Just to get back into what we were doing last week. Guys, those are written down. Sine, cosine, tan, secant, beautiful. No one answer. Now, a student in my 4 o'clock session, where's Bella? Bella asked his professor, should I memorize that unit circle? Oh, no. You may want to memorize a portion of it and then see the relationship that it has with the rest of the circle. I won't try to memorize all of it. All right, guys, first, let me go through this very, very carefully and move on. First one says sine of pi over 4. Well, sine is the y. Let's do that first. By definition. Pi over 4, you must know the ordered pair from the unit circle. Does anyone recall what the ordered pair looked like at pi over 4? And I think we did that last week. Does anyone recall what the coordinates were? Root 2 over 2. That's the easiest one to remember ever. And I'm looking for the y. Well, the y coordinate is root 2 over 2. You can't go wrong on this one. You're done. Next one says cosine. Cosine's definition is x. And you're trying to find that for pi. Now, pi on the unit circle, help me out. Please locate in your mind where pi is and what ordered pair was associated with pi. Was it -1, 0? Yes or no? Is that the ordered pair associated with pi? This is asking for the x coordinate. I see the x coordinate staring at me. The x coordinate is -1. You're done. Next one says find tangent. We're getting a little tougher here. Tangent of 5 pi over 6. Tan's definition is y over x. No problem. Now 5 pi over 6. Got to be careful. This is where you may need to know, which you should. Does anyone recall what the coordinates were at 5 pi over 6 to help me out? And by the way, this is in quadrant 2. Go for it.
Negative square root 3 over 2 and 1/2.
Beautiful. Beautiful. You guys agree? Now tan is placing y over x. With his help there, we're placing y, which is 1/2, over the x, which is this. Clean this up, guys, and we'll clean it up quickly. The 2's will cancel. So we have a negative answer. Rationalize, multiply the top and bottom by radical 3, and you end up with this. And there's the answer. Look how easy that is. But you must know the unit circle. Cosecant, number 4, is 1 over y. Gotta know your definitions. Now, 4 pi over 3, for goodness sakes, please tell me someone from the unit circle, what was the ordered pair at 4 pi over 3?
Minus 1/2.
Here, minus 1/2.
And negative square root 3 over 2.
Negative radical 3 over 2, I'm hearing. You guys agree with him? With the unit circle? Was that the point associated? If it is, cosecant is 1 over y, so that says please place 1 over this. This is my y coordinate that was just given to me. That's 1 over y. So far so good, or not? Okay. Clean this up. Does anyone know what this cleans up to? With no radical in the denominator. What does it look like? I know it's going to be a negative answer. Very good.
Negative 2 over 3 over 3.
2 radical 3.
Yeah.
Over 3. That's the answer. If you cleaned up, simplified. Next, tan of pi over 2, maybe the easiest one. Tan is y over x. Guys, the point associated with pi over 2 on the unit circle, you've got to know this, is 0, 1. I'm looking for tan, which is y over x. I'm placing 1 over 0. What's the answer? Undefined. There's no tangent for 90 degrees. Undefined. Secant is 7 pi over 4. Secant is 1 over x, which I gotta know. 7 pi over 4, I need your help. I know right now many of you have that unit circle right in front of you. What was the ordered pair at 7 pi over 4?
Root 2 over 2.
Was it root 2 over 2?
And negative 12.
And was the y coordinate negative? Alexander, is that one you think that right there? Secant is 1 over x, so the answer is 1 over, and the x was given to me as radical 2 over 2. Guys, please clean that up. What's the answer?
Radical 2.
I think it's radical 2. Maybe I should show that for my last one here. This says 1 is being divided by radical 2 over 2, which is 1 times, flip this over, 2 over radical 2. So at this point, I would have 2 over radical 2. You guys agree? But I can't leave the radical there, so multiply by radical 2 to rationalize it. And you're going to end up with 2 radical 2, we bring it over here, all over 2, 2's canceled, and sure enough, it is radical 2 here. You guys agree? No problem? So I think that's a good review of, you got to know your definitions, and you have to know the unit circle. The rest of this test should just fall into place except for the logs. Okay guys, it's part 2, part 3. Oh, no. We'll extend this. Now I found those, here we go, extension. See what I did here. Beautiful. I want to find the sine of, watch carefully, 9 pi over 4. Sine of 9 pi over 4. Routine, sine is y, definition. Now, can someone tell me on the unit circle, look and find 9 pi over 4 and tell me what the ordered pair was?
It's not there.
Whoa, it's not there. Is 9 pi over 4 there? No. Is pi over 4 there? Yes. But is 9 pi over 4 there? No. So I gotta do something clever here. Hold on, this was not on the circle, unit circle like these were. These were basic. What am I gonna do? I'm gonna do a little division here. It really means this. Divide 9 pi by 4, and it looks like it's gonna be 2 pi, which is what, 8 pi. Remainder of pi, which I always bring up here like that. Guys, the sign of 9 pi over 4, can 9 pi over 4 be expressed like this if I wish from arithmetic? Okay, so I'm going to sketch this to show in the blue what this means. Since I can't find it directly on the unit circle, let's find it. It says first move 2 pi. That's one complete revolution. Leave a little space there. It's like the unit circle. One revolution is 2 pi. Is that true? But don't stop there. Move an additional how much? Pi over 4, which says now move on up to quadrant 1. And you're looking at pi over 4 in the corner here. Is that true? Now, is pi over 4 on the unit circle? Yes. And I think the ordered pair was, help me out, root 2 over 2, and root 2 over 2. That makes some sense of this. And now at least I have an ordered pair to work with. And I'm looking for a sign, which is the y coordinate. Guys, the y coordinate here looks like it's radical 2 over 2. And would you guys accept that for the answer?
Yes.
With that thinking. Okay, so this one was not directly on the unit circle. Number 8. Guys, look at this. A string of these on the test. Just to test your definitions and unit circle. Next one looks like this I brought in. This one's nice. Yes, here we go. I'd like to find the tangent of 25 pi over 6. Tan 25 pi over 6. Does anyone see 25 pi over 6 on the unit circle? Of course you know. Well, I'm going to do, I'm going to break it down and see where it is. Okay, since it's not directly on there, let's divide. See where this is, and basic arithmetic here, what's that, guys, 4 pi? Which is 24. Remainder of pi. Please tell me, may I express 25 pi over 6 like that? Now to sketch it from there, make sure that I can find where it is. That says to move 4 pi. I can do that. This is one revolution, that's 2 pi. I'm supposed to move 4 pi. That means to pick up and move an additional 1 revolution. That's 4 pi. Don't stop there, move an additional what? Pi over 6. Does that take me up to quadrant 1 again, which is nice, with pi over 6, and my ordered pair, do we now have pi over 6 ordered pair? Is that on the unit circle? Was it radical 3 over 2? Do not let me make a mistake here. 1/2? Is it? Now let's try to answer the question. It says tan is y over x. Here we go, better do this. And as I already located, it's 1/2, that's the y over the x. Yes or no? Do not let me make a mistake. 2's cancel. Can anyone tell me what the final answer looks like simplified? Radical of what, 3 over 3? Okay. Now I'll probably show you a few more. I think you might see now that one of these that you cannot recognize right quickly that's not on the unit circle. It's not there. Guys, it always comes down to, you can find it, and it's going to take you to one of these that you know something about. It's either going to take you to pi over 4. This one took you to what, pi over 6? It could be pi over 3. It could be pi. 2 pi, it's gonna take you to something you recognize in this little method here. Let's try another one here, number 9. Got this board filled up here. Number 9 looks like this. Beautiful. Cosecant of 23 pi over 3. Looks like that. And I guarantee you 23 pi over 3 is not directly on that unit circle, so we've got to find where is it. Guys, be careful on this one. I will do the division. Divide 3 into 23 pi. Do not let me make a mistake. Is that 7? I guess that's 21. Remainder of what? 2 pi. And write it as that. The truth? Now, be careful on this one. If I now try to find it, it says, please move 7 pi. Okay, here goes. This is 2 pi. That's 1 revolution. It says move 7. Well, let's move another. That's 4 pi. And what's 7? Move another. Is that 6? And then it'll stop there, move, I got 6 pi, and we want 7. How much more must I move? 1 more pi, which is just half of a revolution. And we'll finally land at this point, right there. Is that true? Now, should I stop there? No, it says be careful. You've got to now move an additional 2 pi over 3 from there. Does anyone know what 2 pi over 3 movement is? How much of a movement is that? Is that going to just pull me down to quadrant 3, or is it going to pull me into quadrant 4?
3.
Okay, you think 3.
4.
Now I hear 4. I gotta be careful which one, because it could make a difference. Guys, one way you could find out for sure, can anyone tell me what 2 pi over 3, this is one way. It looks like in degrees.
120.
120. It's the same as 120 degrees. If you convert it. It's one of those conversion factors. So this says, if you're going to stop here, you need to move an additional 120 degrees. Please tell me, if I move further, is this much right here? Is that 90? That means I would have to move an additional what? 30? Which is going to take me over into quadrant 4. There's where the angle is. It's in quadrant 4. I should point out in quadrant 4. If I'm in quadrant 4, guys, we all know from algebra, are those my coordinates. Now, I need an answer. Woo! I'm doing cosecant, which is 1 over y. Oh, I know what the y is down there, right? Negative. So 1 over a negative, I know my final answer should be negative. Now, negative what? What should I turn to that you could find on a unit circle to get the answer? Go to pi over 3. That's this little reference angle, is that true? So pi over 3 can be used as a reference angle. So I could express this as, look at this guys, I'm doing here, negative cosecant of pi over 3. Mr. Parker, I'll have you check this one here shortly. You guys agree? It's negative for sure. 1 over y in quadrant 4 is negative. Now, cosecant of pi over 3, gotta be careful. Pi over 3, yes, on the unit circle, I had these coordinates. Let's see if you guys agree. Where are those the coordinates? For pi over 3. Yes? No? Yeah. Okay, so we got negative, and it's 1 over y, so that's 1 over radical 3 over 2. Anyone tell me what 1 over radical 3 over 2 looks like cleaned up? Simplified.
2 radical 3 over 3.
Beautiful. Tell me again, someone said it.
2 radical 3 over 3.
2 radical 3 over 3. Nice. And there's your answer. Yes or no? Think so? Mr. Park, do me a favor on on this last, I have one more here, on this one. Guys, would you do me a favor, can you find directly cosecant of 23 pi over 3? See what that is, just directly. What do you think this is? Is it an approximate answer or an exact answer?
Gives -1.
How much?
Oh, I plugged the wrong.
Mr. Park.
Sorry. It's like -1.1547.
Wait, negative
1.1.
1.1547.
1.1547.
Like this.
Yeah. And
Now, hang on, okay. Please tell me, now would you approximate this number for me?
it gives the same solution too.
Same, it's the same.
Yeah.
Good. You guys follow the logic there, guys? So if I give you one that you can't find, I got one more example. You'll say, Professor, I can't find that 23 pi over 6. It's not on there. You're going to say, wait now, I got to take it to something that is on there. And it's going to take you always, it's embedded within the number. Look at this, guys, it's right here. It's going to take you to one of those basic ones. So I may give you something really looking crazy. And it should always take you to one of those basic, and I got one more here to show you, basic ones that you can find on the unit circle. Nasir, what's that question?
So the reference angles are always going to be taken from the x-axis, never from the y-axis.
Thank you. Right here, I know that's some students were thinking. Professor, on this one, you moved an additional, I think it was 120. So this much right here is what, 90? Was it?
Yeah.
And therefore this inside here, would that be an additional 30? So this is 90 from here to here plus 30, that's 120. Now, the reference angles along the x-axis, Nasir, good. Is this up here 60 then? With these two now add 90 also in quadrant 4. That's why this was written as, in terms of, where was it? 60. Pi over 3 is equivalent to 60. Your reference angles are always up here along the x-axis. Good, good. Got anything else? Last one. Looks like this. And you say, Professor, if you give us 2 points each for these, how can I miss it? You might, if I give you 2 points for each one, you may get 1 point just to show me what sign it is. Where is it over here? I'll give you 1 point to show me the correct sign. And then the other point, the number, to get the 2 points. Last one looks like this. Secant, I got that one out of the way. Hang on, where am I? Yes, number 10. I had a nice one here that I surely did not erase it. No, I didn't. Okay, secant. Yeah, here we go. Secant. 19 pi. Guys, what's the definition for secant? 1 over x. I know this. Now, 19 pi. Is 19 pi on the unit circle right now? No. Where is it? Oh boy, this one says just sketch 19 pi. Here we go. Help me out. That much is 2 pi. Is that true? I want 19 pi. I'm not going to do all these guys because I think if I move an additional revolution, is that 4 pi? How many of these must I draw in the attempt to get to 19? 9 of those. Let's say I've already drawn all 9. And the last one, right here, that's the last one. That's 9 of those. Should I stop there? No, that would be what, 18? I guess 18 pi. I want 19 pi, so I must move an additional what? Pi, which takes me over there. Is that 19 pi altogether? Does it say to move any more from there, like this one says move an additional pi over 3? Did this one say move any additional space? No, I'm finished. Unit circle says this point should be negative 1, 0. And what is secant? Secant's 1 over x, so it's 1 over negative 1, that's the x coordinate. And the answer is negative 1. Is that true? Okay. That's a little recap. That's a recap. I haven't started the lesson tonight. Just a little recap. How's it look? Is it coming together for us now? I see heads shaking yes, and I guarantee you when you walk out of here Wednesday, I'll go, I'll see heads shaking. Yeah. Now here's some students out there talking. I'm gonna bring in a box of tissue, crying. I said, what'd you get with this one? I got 0. What'd you get? I got square root 3. Bella, what'd you get? I got negative 2. Kelsey, what'd you get? I got 10. I'm going back in and ask the professor what the answer was. All of a sudden I said the answer was pi. Pi. You all missed it. Geez, is that going to happen Wednesday? It better not happen. But my summer class is filling up fast. I don't have much space. Okay. Guys, any concerns here? Now, where's this going to take me? After all of that work, whoa. Hang on. Number 11, for a reason. I'd like to find this. This is for a reason that leads me into where I want to go. Sine squared pi over 4 plus cosine squared pi over 4. Guys, when I write this in the version you see it, this really means find sine of pi over 4. Don't let that square throw you. It means it's squared. This says for cosine squared, find cosine pi over 4, and then squared. Now, can I find these two thinkers directly on the unit circle? Thank goodness, not any of this division involved. Sine of pi over 4, guys, the y coordinate of pi over 4, I think is what? Radical 2 over 2? Check out your unit circle, you got squared. Cosine, the x coordinate, another radical 2 over 2. If I'm correct, squared. So you're going to end up with, if you square radical 2 over 2, is that what, 2 over 4? We'll call it 1/2. And if you square it again, another 1/2. Add them up, you get what? 1. I may have some of those where you have to do a little arithmetic and get an answer.
Do we have to show the method, or can we just say equals 1?
Whoa, I know exactly what you're thinking here. This is going to lead me into what we're going to go with. Yeah, hang on. Guys, any concerns here? No. Now, let me do this. Where am I? Ah, beautiful, beautiful, beautiful. I ended with that last problem there. Sine squared plus cosine squared is equal to 1. And Nasir just asked us, Professor, are you going, like you teach, are you going back to where you started? I'm going back. For a reason. Erase just enough to get started here. Ignacio, here we go. The reason I did this, let me try the green. These are my definitions. Sine is y, I'll accept that. Cosine is x on the unit circle, I'll accept that. Now I got tangent to be y over x. But why can I not think of y over x as now more sophisticated as this? Is that still y over x? So now I'm going to think of tangent as sine over cosine. Same thing. Secant is 1 over x. Why not think of it as 1 over cosine? And have it like that. Cosecant, 1 over y, that's 1 over sine. Cotangent is x over y. What I think of it as cosine over sine. Is that true? Just rethinking some of those functions. Now, I'm going to add to it. On number 7, I think a good way to do this. Did I not say earlier that you could think of the equation for the unit circle as looking like this? Was that the equation I gave you? X squared plus y squared must be equal to 1, or it's not on the unit circle. Why not write that more sophisticated like this? X is cosine, so why not write this as cosine squared? And y is sine, sine squared. You said the same thing. I'm going to turn around and make it look better. I prefer it in this order. Most textbooks will give it to you in this order. And there is another property. You guys agree? If you're going to tell me x squared plus y squared is equal to 1, just written a little bit more sophisticated. Now, number 8, I need to get these out of the way. I'm going to go back to the one in green I just blocked off and do something to it, modified, and come up with another property. I'm going to go back to number 7. And by the way, does number 7 fit? Ignacio, this is what you're thinking of. Does it fit this problem exactly? So if I had known that property, could I say without any thought, it's 1? Sine squared plus cosine squared is equal to 1, directly, by that property. What might mess me up, though, that I could not say directly 1?
They're different angles.
If these angles were different, then I could not. But mine was the same. Just that property. Now, 2 more additional properties we need to look at, guys. Here goes. I'm going to go back to the green. I'm going to modify it. I'm going to take the green. I'm going to put this in green. Here's the green from number 7. We accept this. I'm going to modify this. You say, Professor, how are you going to modify it? I'm going to divide everything by sine squared. We just modify it. You try to come up with another property. Guys, if I divide everything by sine squared, which should be valid as long as I divide everything by sine squared, everything's being divided. Guys, this first term is 1. Can anyone be clever and tell me what on earth could I call cosine squared over sine squared?
Cotangent.
Thank you. Is that cotangent? Because I think we said cotangent. Where was it over here? Was cotangent cosine over sine earlier? And Bella says, Professor, it's just being squared, so this is cotangent squared. Can you tell me a good name for the other side, 1 over sine squared, knowing this previously? Is that cosecant squared? And there's another property. And we'll make use of those properties here shortly. I have one more I'm going to do. Number 9. We'll go back to the green. Put it in green so you guys can see I'm going back to that green one. Sine squared plus cosine squared is equal to 1. And we'll modify it one more time. This time to modify it, I'm going to divide everything by not sine squared, but by cosine squared. To derive another property. See what that might give me. We go on the side here. Guys, sine squared over cosine squared, another name for it, knowing that sine over cosine is tangent. What would be a good way to express term number 1? Is this tan squared? I put theta there, it was x, okay. And then plus cosine squared over cosine squared is 1. And what's a good name for this, where back here we said earlier 1 over cosine was secant. Secant squared. Now you have another property that I'll be using here shortly. Relationships, they call them identities. We use that word. These are the identities. Statements are really identical, or properties if you wish. And these will help me later on, definitely. Guys, any concerns here about the properties? You see the relationship going on with the properties? Please tell me you do. You okay? Now, how to use them? That's part one. Notice I did not change that. I'll go to part two. I'll put this in blue here. And here we go. Let's make some sense of this. Okay, guys, part two is going to look like this. Beautiful. We'll give you some information. We'll give you this. Given cosecant theta, or cosecant x if you wish, is equal to -4, comma, and tangent theta is greater than 0. Now, use the identities next door here, on the side. Find the exact value, no calculator, of the remaining trig functions. Now guys, help me out. I gave you cosecant. How many trig functions are there altogether? You go to Stanford and they're talking about trig functions. How many are there altogether? 6. We've already talked about it, haven't we? We got the difference of 6. Now, I gave you one of those cosecants. So what's missing? I do not know what sine is. I'll get ready for it. I do not know cosine. Supposed to be 6 of these. I do not know tangent. I do not know secant. Number 5, I don't think I have cotangent. Those 5 are missing. You guys agree? Now I gotta find the values for those 5. Now, someone's going to tell me, and you've got to give me a rationale, because I'll be asking you to show me the rationale, which is one of those identities. I will tell you this much before I get a response. Let's try this. Alex, I saw your hand go up. Alex, of the 5 I'm searching for, with what they gave me, there's one of the 5 that I would get out of the way right now, quickly, and then find the other 4. There's one that's much easier than the others. Alex, which one?
Cotangent.
You're saying tell me again.
Cotangent.
Cotangent, I would, okay, I see why you said that. We can find cotangent. We are going to find cotangent. There's another one that I think is a little bit easier to find with what was given to me. Is there a relationship between these two? Was cosecant given to me as, where on earth is it, as 1 over sine? So in other words, aren't they reciprocals? So if I gave you this, can you quickly flip it over, form the reciprocal, say, Professor, this one must be this. And you're finished. Yes or no?
Yes.
If I say now, which one of those properties did you think of? I'll be asking for it to be shown. You say, Professor, cosecant is equivalent to 1 over sine. That's my justification. Now, Alex, class, the other 4 may be a little bit tougher. Whoa. Got the easy one out of the way. Does anyone see, of those 4 remaining ones, one that you'd like for us to find? And I'll try to find it with the help of one of those identities. Alex? You want cotangent. Now, he wants me to find this one. Guy, which identity over there do you have in mind?
1 plus cotangent equals cosecant.
Oh, hang on, look at this. He says, Professor, 1 plus cotangent squared is equal to, what was it, cosecant squared? Let me go back and take a look and see, make sure it's up right here. He says, Professor, use that to find that last one. Now, Alex, make sure I put everything in there correctly. So this becomes 1 plus cotangent squared is equal to, he tells me cosecant squared, which it is. I give you cosecant, its value. That was a -4, so it's a -4 squared. Yes or no? So we end up with 1 plus cotangent squared. Nice here, 16. Solve this, move the 1 over by subtracting. We got that is equal to 15. Do a square root. Now here's my issue, Alex. Hang on now. If in algebra you were doing this across the street, and the teacher says find x squared is equal to 4, and you want to do a square root, you know that's 2 answers. It's a quadratic. Then you're going to say plus or minus 2 to show both answers. Here, mine would be plus or minus, something strange, but radical 15. Is that true? At this point. Alex, you are correct here, but I cannot have 2 answers. Now, which should I accept? Should I accept positive radical 15, which cannot be simplified, or negative radical 15? And someone tell me what determines that?
Positive.
Okay, I heard positive. You guys accept positive? Now, what's going to give that away?
The restriction.
Right here. This tells you, if you take a close look, both these together will tell you which quadrant you're located in. Now, cosecant is given to me as -4. Cosecant is 1 over y. Let me find it. Is that true? Now, can you tell me of the 4 quadrants, if I place 1 over the y, where am I guaranteed to get a negative response? And I'll tell you this much, there's 2 quadrants that will give that to me.
3 and 4.
Okay, I heard 3 and 4. Hang on. Now, so you're telling me I could either be in quadrant 3 or quadrant 4. Guaranteed, if I place 1 over y, where y is negative in both those quadrants, will I get a negative response? But they also add this. Tangent's got to be positive. And tangent is y over x. So which of the 4, and there should be 2 of them, if you place y over x, you're guaranteed to get a positive.
Wonderful.
I heard, thank you. 1, and what now?
4. Oh wait, no, 3.
3. You guys with me? Is it quadrant 1, quadrant 3? If you place the y over the x, are you guaranteed you get a positive answer?
Yeah.
Aren't you from algebra? By the way, in quadrant 3, why? Because aren't the quadrants, the coordinates, aren't they both negative in quadrant 3? So if you place a negative over negative, it turns into a positive. So I'll accept that also. Now, let's go back. Cotangent. Cotangent, by definition, is x over y. So if I place x over y, now I've got to be careful here, guys. Which quadrant did these match up in?
3.
I'm in quadrant 3. Which tells me, if I'm in quadrant 3 from algebra, the point is, help me out, for coordinates, negative, negative. So therefore, what sign should I accept here?
Negative.
Negative. So the final answer after all that thought is negative radical 15. What a workout. You guys agree? Help me out. Help me out. No, I saw some looks. What's cotangent's definition over here? Is it x over y? And where are you placing? Are you placing a negative over a negative?
Yeah.
Which gives me a y. Is it positive? If you place a negative over a negative, radical 15. Is that true? That's why I did that. Okay, now we got that out of the way. Oh, it's positive here. Now, can someone tell me, Alex, thank you for that. I see three more are missing. Tell me, identities on the side here. What would you like to find next? And I'll find it. And you gotta use one of these identities.
We find tangent.
Tangent. Now, if you wanna find tangent, Ignacio, tangent right now looks like this. Sine over cosine. Yes or no?
Yes.
Let's see if we have enough. Whoops.
Just flip the cotangent, right?
Oh, hold on. Okay, oh, beautiful, beautiful. Hang on. Got you. Sine over cosine. He says, Professor, also, to save me a little time, what's another way to express, where is it, cotangent? What's another way to express cotangent besides this way? Besides cosine over sine? Well, I'm going to tan here. Not so tell me what you have in mind.
Since tangent is sine over cosine, cotangent is cosine over sine.
Could you think of this as, and I think your textbook does this,
One
could you
over-
think of this as also 1 over tan?
Yeah.
He says, Professor, these two are just reciprocals of one another. So could I think of cotangent as 1 over tan? Yes or no? They are reciprocals. That might be an easier way out. Alex, we found cotangent earlier to be this. So what should tan be? 1 over. Should be the reciprocal. I can save a little time here. And then rationalize that. And we have that. Now, Ignacio, if I want to use this to find it, I must go ahead and find that first. If I want to use sine or cosine. Cosine's missing right now. Okay, guys, I'm down to cosine and secant. Any ideas? Which of those identities over there might you use? And I'll use it to find one of them. Who has an idea? And by the way, tell me, after I find one of them, either one, I don't care which one you find first, as long as you can justify it, either one of these, are these two also reciprocals?
Yeah.
Where is secant? Is secant 1 over cosine? So which way, and one you find first, just flip it over, you find the other one. Is that true? Okay. Does anyone have an idea how to find either this one or this one using one of those identities? Yes?
Sin squared plus cosinus squared equals to 1.
Hey, I love that. Hang on. Sine squared plus cosine squared, nice, equals 1, and that came from wherever right here. That's one of the trig identities. And then I think, help me out here, do we know sine is negative 1/4? We found that earlier. So I can put that in right here. We did that earlier. Cosine squared equals 1. This is 1/16. Cosine squared. Guys, we'll do some math here. I will subtract that 1/16. Help me out. Does that give me 15 over 16? Yes or no? Take a square root. At this point, it's plus minus. Since I see a square there. Radical 15 over 4. I do a square root. I can accept both. Now that's cosine. So I'm going to put it right here when we finally decide, is it positive or is it negative? Well, we said earlier we're in quadrant 3, didn't we? And cosine is what? The x? And what is the x coordinate if you're in quadrant 3? Negative. So this is a negative radical 15. Squeeze that out here. Over 4. Thank you. Sine squared plus cosine squared is equal to 1. Now guys, can I now fill this one in fairly quickly? Should secant be the reciprocal, 1 over cosine? So just flip this over, still negative, and we got this. Simplify, rationalize, and Please tell me, do we end up with that? Do we have all of them listed, I think, with the correct signs? I hope. We are in quadrant 3, aren't we? So the X and Y coordinates both are negative? Yes.
Is sinus 1/4?
What do I get now?
Sinus is negative.
Secant? Secant is one over X. Let me find it here. Or one over cosine. And we said back here, it was finally this.
No, I mean the first one, sin,
Sine.
Oh, well, I mean cosecant?
yeah.
Oh, beautiful. Here we go. Hang on. We got that one out of the way, didn't we? Didn't we get that one out of the way earlier? That's a negative what, 1/4?
Yeah.
Yeah, it is. We filled that one in first.
So how do we get the cosinus?
Oh, we had to use sine squared plus cosine squared is equal, you give me that. Sine squared plus cosine squared is equal to 1, I had to use this identity. And then plug in for sine negative 1/4. And we got cosine to be that.
Okay, got it, thank you.
You got it?
Mm-hmm.
Okay. Got anything else? I'm checking my time here. Okay. Making sense the way it's coming together? Now make sure we have all the signs correct up here. I'm on top of the board. Alex?
I was kind of confused on how cotangent became a positive group between.
Cotangent should be x over y. And x and y in quadrant 3, that's why this is important, are both negative. So if you place a negative over a negative, x over y, you get a positive. So that assures you the answer is positive. Yes or no, guys? Now, before I leave it, someone think about quadrant 3. That's where we're located. That's where we did our thinking. And we know in quadrant 3, the coordinates from basic algebra are negative, negative. Can you tell me, guys, in quadrant 3, give me an answer, of the 6 trig functions, which 2 should be positive when you place a negative over a negative in quadrant 3? Only tan and cotan. Please, I have my back turned to the board. Did I have the other 4 to be negative? Are the other 4 answers negative?
Yes.
And tan and cotan are the only 2 positive. Is that true? Okay. Alex, that help?
Yeah.
X over Y? Okay. Guys, take a close look at it. I think it's coming together for us. I'm close to, very close. After the break, very close to closing down chapter 5. Any concerns here? Now, that math 7 instructor, and when I teach it also, we don't have time for you, when you see trig, and you're going to see trig again in calc, because they're going to ask you to do some calculus on it. They don't have time. They're going to frown upon you, and they'll come back and say, Ramsey, you didn't show them that? Of course Ramsey showed them that. Who told you I didn't show you that? Ignacio said you didn't show him that in math 2, professor. I'm going to find Ignacio. I'll find him. Of course I showed you. But they're not going to have the time for you to go through step by step and do this. They're going to ask you to take a derivative or some calc technique, and they're going to say, you should know this quickly. They may not even ask you to show all this. They just want the calculus done to it. Okay, so it's very important there to get that done. Guys, we step to the side here. Wow, this came together so nicely. I was a little hesitant about presenting this like this, but it came together. Guys, any concerns? No? Jeez. Mr. Park? Hang on. We got what, 5 minutes maybe? Less than that maybe? Before I erase everything, guys, let me say again, you must know. Oh, by the way, this is not on the exam. I think the exam just goes up to 5.2. Is that true? I think we're doing 5.3 here. Some of this was 5.2. These identities, I think, is in 5.3. You gotta know these. These are called the identities. I have them all here and all here. You gotta know all those. And how to apply them if you want to apply them. Like I applied here on this one.
So will this be the extra credit?
Oh, no. Oh. Hey, I've got some extra credit. I mean, there is going to be extra credit Not as, I'm not saying extra points. The difficulty level is a little more intense on these coming up for your extra credit. Wait till you see what I have in mind for you. And I think since they are a little bit more difficult, probably at least 6 points extra credit. I think I have 2 problems, 3 points each. If you get those to work out. Guys, any concerns here though? Gotta know the identities. Now, Mr. Park, do me a favor. Let's see if I'm ready for it. He's made some copies for us. See if I am ready. This one. Which one am I looking for? I thought we had 2 different, oh, there, I guess.
It's like piled.
Oh, they're set, oh, I got you, darn it. Okay, they're not all together. Okay, guys, I'm gonna hold on to it after the break to get this done.
Okay.
We'll wait. Okay. Any concerns? Nothing? No questions? Now, let me ask you to do one thing before we take a break. Find the exact value for this. Now, this type will be on the exam. That would be one of these types. So guys, I'm gonna try one here, and then we'll see, maybe have a student come up and work it. I'd like to find the exact value for, let's try a secant. Here goes. Why not 41 pi over 6? Good luck. Then we'll take a break. So what's Professor Wayne talking to me about? You and I will have to talk.
Oh,
We'll
okay.
talk after class. So guys, don't want to rush you here, but we're gonna run out of time here. I was gonna have a student help me out. I would do it like this, like I presented it. Secant's definition. Definition. We're correct. Now, this is not on the unit circle. So this is one of those where we have to, for Wednesday's exam, we gotta do this. Try to locate it. And do not let me mess up on my arithmetic here. I guess that goes, what, 6? Help me out. Is that 36 pi? Remainder of what, 5? So I could rewrite that, see if you guys agree, as this. Yes or no? Now, let's locate it. It says to move 6 pi, which is easily moved, because that's 2 pi. That's 4 pi, revolution. There's 6 pi. But don't stop there. Move an additional what from there? 5, 5, or 6. If 150 degrees would help you to move, that's in degrees. If I move 150 or 5, 5, or 6, will I eventually end up in quadrant 2? Yes or no? Please help me, is it? In quadrant 2? Now, many students will say, Professor, if this is right here at 5, 5, or 6, which I think it is 5, 5, or 6 on the unit circle?
Yes.
Can someone tell me the coordinates?
Negative,
Negative,
radical 3 over 2.
negative radical 3 over 2, huh?
1/2.
And a half. Is that true, guys? And what do I want? I want secant, and we said secant's definition is what? Place 1 over x, which is like a reciprocal. So guys, if I place 1 over this, and if I'm clever and do not mess up on the arithmetic, the answer is going to be negative. I just wonder what that is after you clean it up.
2 radical 3 over 3.
All right, 2 radical 3 over 3. And you're done. That help? Okay, take your well-deserved 10-minute break.